Hey class, video 2 for our 2D waves here. So last video I talked about how to actually do a reflection question and what the basics of that are. I'm going to do 2 examples here where our barrier that it's hitting has changed. So if you look at, I'm going to pull again, this up for a second. Okay, turn on. Yeah, okay, me again. There we go. So what you can see here is now this is the bottom of that same little worksheet that I was on last time, like the law of reflection. At the very bottom of the second page, there's this, where the rays are coming in, and if you can imagine kind of like sunlight or water waves, they're coming in at the same angle, but the barrier that it's hitting is changing. Now we call it specular reflection in the sense of like the barrier that it's changing, the barrier that it's hitting is changing. So I'm going to do this ray and this ray to show you how the reflection changes quite a bit. That way, and also it gives you a couple more examples of me kind of actually working with this reflection. Okay, so again, these are both incident angles. What I'm going to do right now is I'm going to draw the normal lines for both of these. So again, normal line for this, I have to put it exactly in line, and the normal line, I'm going to put a dot at 90 degrees. So there's my normal line. So you can already see that technically this ray is going to come off in this direction. Okay, it's going to go on the other side. It's going to go on the other side of the normal line. Okay, so it's going to come off this way. And that kind of makes sense. If you see this and hit this, it's kind of going to bounce this way. This ray is coming in at the exact same angle, but because it's hitting this barrier very differently, it's going to come off very differently. So here's our normal line. And so again, we're going to get a very different reflected ray for this one compared to this one, just because of the barrier that it's hitting. All right, so let's figure out some angles here, and then let's draw some new reflected rays. So for this one, how I do this? Protractor goes right on, it'll go on this side. It'll go right on the normal line. So you kind of see that the bottom of my protractor lines up with the normal line. And then I just have to figure out, like, where is this line right here? It's at, like, I don't know, we'll call it 25-ish degrees. 25 degrees. So flip it over, have it again on the normal line, and I'm going to put a dot at 25 degrees. 25, and then make my next reflected ray. So again, line it up, there's my dot. And so this again would still be 25 degrees on the other side. And so there's my reflected ray. If this were to come and hit this barrier, this is the reflection that I would be expecting to come off of there. Over here, let's find this one. So again, put my protractor line up with the normal line. We're at like kind of 43, 42. Fairly similar to the first one that I did on the other video. 42 degrees. Flip over my protractor. This. 42 degrees, and there's my dot. There we go. So again, there's 42 degrees as well, and so there's my reflected ray. Okay, so again, they come in at the same angle, but because of the barrier that's hitting, this one comes out this way, this one comes off another way, but that's just because, again, that's how reflection works. It's going to bounce off exactly the same angle, but it has to be, again, perpendicular to exactly that normal line, in the sense of, like, that normal line is going to dictate, again, how, like, where it's going to bounce off of, okay? Again, if you were to look at this one just come up next, it's probably going to bounce almost kind of straight back, because it's almost hitting straight at 90 degrees, okay? If I were to do this and put this here, it's like 90s right there. So really, this thing is almost bouncing straight back up, okay? And so I just wanted to show, again, a little more examples of how to do the reflection and how it could change depending on your barrier, okay? I do want to show one other example in the sense of, from your assignment, and now you can kind of see me here, which is weird, but okay, I'll go back here. From your assignment, where is the assignment? I don't know where it is. 1 second, I'll get it. We have grade 11 physics, 2D waves, there we go. Okay, 2 years aside. This will be out to you guys today as well. There's a question that looks kind of like this, not like this. It is hopefully coming. There, okay, so there's that. All right, so you'll see, so this one you should be able to do no problem. Okay, this is exactly the same as what we just did. There's the incident rate, it's coming in. Some people get questions about this one though, so that's okay. Let's answer this question, how do I do this? So this one actually looks like waves, okay? So you can kind of see some waves heading towards this barrier. And I got a lot of questions like, well, how do I now actually like do this question? Well, what you're gonna do is just create that ray. How do I create that ray? It's not too bad. Put your protractor in line with one of these. Put a dot at 90 degrees. And then just make that actual line. And so now there is your actual ray, okay? I forgot to add that in last time when I did the grade 11 video, so I had to kind of remake the video, but here it is for your actual assignment. Sometimes they show the crest coming in. Just, again, put your protractor on, make a little dot at 90 degrees, and there's exactly your ray, and then everything else is exactly the same after that. Just make your little normal line, make your ray on the other side, and we're all good. All right, hopefully the reflection makes sense. If you have any questions, let me know, and I'll talk to you guys for a little bit. But the next 2 videos are going to be about like wave investigations and how water waves or other waves interact with like barriers or through small holes and that kind of stuff. All right, class, thanks so much. Let's go back to here. All right, have a good time.